So every year, millions of animals, birds, sea turtles, whales, even butterflies embark on migrations that sometimes can seem to defy logic. And some of these animals are even returning to the exact place where they were born. And they're doing that without a map or GPS or a smartphone, or sometimes even any prior experience of being in that location. So, Dustin, let me ask you, do you have any ideas on how exactly they're doing this?
Well, different animals have different strategies, right? We'll talk about some of those. But migration is the seasonal movement of animals from one region to another, usually for breeding, feeding, or avoiding the weather. Animals face predators, storms, and human made obstacles like cities and pollution, so navigating accurately is critical for their survival. But those risks are very different, or can be very different for different species. Birds, for example, are making a critical judgment to gamble their lives to migrate in hopes of better food, habitat, or breeding success. It's like a Sophie's choice for them, but instinctually, they know that it's better for them over the winter to survive down south, and it's better for them to raise their babies up north in the northern hemisphere. Um, because the food situation is much better for them with the way that bugs and larvae are plentiful in the north. But it's not just birds that migrate, it's sea turtles. They migrate, their biggest risk is temperature. Whales, monarch butterflies, and salmon migrate. Plus, there's short distance migrants, like we talked about last week, in salamanders and frogs and toads and things like that. They're moving to new areas to reproduce. And in Africa, it's often about the seasonal weather patterns that produce drought and then eliminate it, that forces the animals into seasonal migration so that they can literally get a drink of water. And so, how do they do it? A lot of animals use Earth's magnetic field to navigate. Some species rely on their generational memories of their elders, like the whooping cranes we've talked about recently. And this is true for some African savanna species as well, because with changing weather patterns, they rely on their elders to make the critical decision to follow known migration routes or to search for alternatives at their whole group's peril.
Okay. So you mentioned magnetic fields, and that's probably going to be the focus primarily of today's topic. And I remember from school as a kid that, at the Earth's core, there's this molten iron core, right? And that is really where our magnetic field on Earth is generated from. And it creates these like invisible lines of force that run from that magnetic core. And so that we've got magnetic north pole and we've got the magnetic south pole, right? So we know this exists. We have magnets. We're aware of it. But like how animals aren't walking around with their little pockets full of magnets or a compass or whatever. So how do they detect it?
No, but just like a compass needle aligns with those lines, some animals have biological mechanisms that allow them to tap into the magnetic fields as a sixth sense almost for navigation purposes. Some animals have cells containing magnetite, which is a magnetic mineral that responds to these magnetic fields. Birds tend to have it in their beaks and in their brains, while sea turtles have it in their heads. And it works like a built in compass, helping them to orient themselves accordingly. When that malfunctions, however, it's believed that that might be why certain birds end up lost well outside their normal routine migration, such as when rufous hummingbirds from the western part of the US accidentally fly all the way east before they fly south, and we end up late in the season with some hummingbirds that simply don't live here any other time of year. So it's really important for them to keep things in working order. And while that magnetic field is crucial, animals can also use the sun, stars, and even landmarks to navigate. It's a multi-sensory system. And by landmarks, it might be something as big as a mountain, could be the ocean, the coastline, the Mississippi River. So it is more dynamic than just magnetic fields.
Okay. All right. So they're attracted to the magnetic field or something like that, right? But I guess I don't entirely understand how they use it. Like, how are they, like, what's happening?
Yeah, we don't know exactly if they're attracted to it so much as they can sense it and they know where they're supposed to go or where feels like the right place for them as sort of an instinct. So birds like the Arctic tern, which migrates from the Arctic all the way to the Antarctic and back, use it to stay on course. So research has actually shown they can detect both the intensity of the magnetic fields as well as the inclination of them, which helps them to determine sort of the latitude and longitude that they're at, so they know where they're headed, but they also have a sense of kind of when they've arrived from that. Sea turtles hatch on beaches and immediately use magnetic fields to head toward the water. And as adults, they return to those same beaches to lay eggs, guided by the unique magnetic signature of that particular place on the surface of the earth. Monarch butterflies are really different. They migrate thousands of miles from North America to Mexico, but they use a combination of the sun and magnetic fields to navigate. Other animals like whales, humpbacks particularly, use magnetic fields during their long migrations. It's believed that they follow kind of magnetic hotspots in the ocean that are mapped out by natural variations in Earth's fields. So over time, it seems like they've learned where the good food sources are relative to these known magnetic hotspots. And so they use that to inform their travel. And then strandings can even occur in areas where magnetic anomalies have confused that navigation.
Okay. Um, all right, I think I get it. So you mentioned sometimes there's a confusion with or an anomaly, right? So and you mentioned what happens to whales. So obviously disruption to magnetic fields happens, or else you wouldn't have given an example of how whales experience that. And you mentioned that hummingbirds sometimes get lost. What are like some of the causes of these anomalies though? Like how does that happen?
Sure, sometimes there's a causal factor that's maybe brought on by humans, but sometimes it's an internal malfunction for some reason as well. So it
Okay.
could happen, think of it both externally to the animal and internally to the animal. But for example, human activity like underwater cables in the ocean, power lines overhead, those can create anomalies that confuse animals. And large underwater cables can sort of create different electromagnetic noise that can confuse fish and sea turtles. City lights can do this, particularly to confuse birds that are navigating by light, both celestial and magnetic cues. And whales can even beach themselves in areas where a magnetic field is weaker. Some studies show that they get disoriented and sort of swim in the wrong direction. That's how, particularly when the tides go out, they can find themselves disoriented in these shallow zones that can be harmful for them. And homing pigeons are a really uh, familiar example to people, about being, really experts at guiding themselves back to their home roost. But they can have trouble navigating near power lines because of that electromagnetic interference.
So they're sensing the magnetic fields in some way, right? Like do we know how? Do they feel it? Do they see it? Like do we know what their experience is or not really?
Uh, we have some understanding of it. We don't know what it feels like, but the sense is sort of called magnetoreception. And this is the ability to detect magnetic fields. And different animals, we believe, can sense it slightly differently. Birds like robins and warblers, it's linked to a protein called cryptochrome that is in their eyes. And so researchers think this allows them to kind of see the magnetic field as like a visual pattern, or maybe like a faint blue sheen. And if they can kind of go toward the blue, they're heading in the right direction, so to speak. Experiments with robins in controlled environments around magnetic fields have shown that they can adjust this orientation based on changes in those fields. Some aquatic animals like sharks and rays have highly sensitive electroreceptors kind of in their snout that allow them to sense the magnetic fields in the water. Sharks in particular are very sensitive to this. And they have some amazing migration patterns that are really only just coming into focus because of modern like radio tagging and stuff like that. We see like the Great White Shark Conservancy and those programs have really finally unveiled what those migration patterns look like. But back to the Arctic terns, they can sense both the strength and the angle of the magnetic field. So think of it like a GPS that gives you your latitude and your longitude point. It helps them literally know where they are on kind of the grid of the whole planet.
That's so wild. Okay, so what about other animals? Like, do mammals have the ability to see or sense magnetic fields?
Some of them do. We don't know exactly how, but cows and deer are both known to align their bodies north-south when they're grazing.
Really?
Yeah.
That's interesting.
And we didn't plan this either, but dogs are known to kind of always face in the same direction when they're pooping. Now, I don't know if that's because of magnetic stuff or the sun orientation, but there's a chance that dogs do it naturally too for unknown reasons.
That's crazy. I thought they were just looking for some privacy.
No, I don't know. But bats are another one that have a great magnetic sense. This helps them navigate, and there's been some experiments. I recall an NPR story from a number of years back that highlighted how they took big brown bats from a known roost in a barn, and they put them in like big glass jars and exposed them to some magnetic field disruptor technologies, and then they drove them like 20 miles away, or they tagged them before they put them in the jar, and they drove them away to see if the bats, who are known to always go back to their same roost every morning, if they were able to immediately go back to their roost, or if they were going to get lost, or what happened. And it basically turned out that they all wandered kind of aimlessly, like they couldn't find their way for several hours, but they eventually just kind of shook it off, and their instruments got aligned again, and they headed back. Most of them within a few hours. Some of them took until the following day, but they pretty much all returned back to the roost. So it was proven that the magnetic disruption impaired their navigation abilities, but that it was temporary.
I don't know that I would like if somebody put me in a jar and like drove me out in the middle of the woods and was like, all right, go find your house. But okay.
Right. Good thing you have GPS then.
Yeah, a good thing I have a smartphone. All right. So I'm assuming humans don't have this ability. I mean, I can verify that I am a human, and I know I can't sense a magnetic field, or at least I've never had that experience. So we're off the list, right?
Yeah, there's no proof that people have this sense, although I certainly have known some people that have just a very innate sense of north south, and you can sort of say to them like, hey, turn west, and they know which direction it is. I'm certainly not one of those people. So is it nature or nurture? I don't know. So sometimes scientists expect we might have some remnants of this kind of magnetoreception in our DNA, but there's no like clear evidence of that.
I wonder for the scientists who think that there's like some residue of that in our DNA. I wonder if we just evolved away from that as our species became less and less nomadic over evolutionary history.
Could be.
Because we might have needed it at one point until we got into actual agriculture and we stopped wandering around all over. But I don't know that we ever, like historically, even like way back at the dawn of time, like migrated because of weather. I don't know. I don't know. Okay. I will say, like, I'm really amazed that animals even like have this ability to like not only travel the crazy distances that they do, but to get exactly where they need to go. When they don't have any of these tools that we have, I mean, I can't even navigate a couple 100 miles without a map of some kind and information to kind of get me there. So it's crazy.
Yeah, humans had to resort to tactics like numbering the interstate highway system so that the numbers tell you which direction you're going.
Yeah, exactly. All right. So, in asking you to help me research this topic on migration and magnetic fields and stuff, did you end up developing any fun migration facts that
Yeah,
you want to
I'm
share
going to
with
go
us?
back to the Arctic tern for this
Of
because
course.
today's low key my favorite day of the year because we're turning our clocks forward tonight.
Oh, it's my worst day. I hate it.
Well, tomorrow's my favorite day of the year because we finally have time after dinner or after work to walk the dogs in the daylight. And the reason I'm tying this to the Arctic terns is because they migrate all the way from pole to pole. In the summer, they experience 24 hours of daylight. And then in the middle of the year, they have a normal day night, but then they migrate as they're migrating down south. They hit the South Pole, and now they have 24 hours of sunlight during the winter. So more than any other species on the planet, probably, they get to experience daylight the most.
That's a cool trivia fact.
Yeah.
Anything else that you want to cover on migration?
Just how interesting the migration of the monarch butterfly is, because this is not a little insect that just knows its way down to Mexico from North America. It's actually a multi-generational and multi kind of life cycle migration pattern for them. So the migrates that migrate to Mexico in the fall are not the same individuals that return north in the spring. It takes monarch butterflies 3 or 4 generations to complete a full migration cycle. So the ones that leave Mexico in the spring fly north, lay eggs, and die. Their offspring continue that journey northward, repeating the process until the final generation emerges in late summer or early fall. And that final generation, known as the super generation, lives much longer, up to 8 months, and they make the entire journey back to Mexico, even though they had never been there before. Scientists think monarchs use a combination of the sun's position and Earth's magnetic fields to navigate. They also seem to inherit kind of a genetic map that guides them to the same overwintering sites in Mexico. These sites are where a fir tree called the oyamel fir tree is located, and these act like a natural umbrella for monarch butterflies, protecting them from rain and extreme temperatures. The butterflies then cluster together in huge numbers around these trees, sometimes covering the whole trees, and helps them to conserve heat together. And the fact that monarchs can find these specific trees despite having never been there suggests an incredible innate ability simply encoded in their DNA.
For me, I think today's discussion was really a reminder that there's still so much to discover about the animals that we share the planet with. You had touched on some research, but you had also said that there's certain things that we still don't know about how animals figure out how to migrate, and scientists are still hard at work doing that research. I think it's exciting that there's still new things about our planet and the animals that live on it to discover, for sure.
Definitely. So I'd be curious to know from those watching, right? What animal migration fact blew your mind the most? And what animals do you witness migrating in your area? Let us know in the comments, and be sure to subscribe and turn on notifications so you know when we put out more videos just like this.
So that is all for today's episode. But before we head off on our next adventure, this is just a quick reminder from us to you that you can find Dustin's wildlife photography and links to all of our content channels on our website, hikeandhearth.com.
And we love being a part of the YouTube nature community. So keep sharing your comments and your experiences with us on nature, wildlife, and conservation. And if you're not already subscribed, be sure to join us.
Absolutely. Yeah, we love the comments and chatting with you guys. It's a lot of fun. And if you are on Substack, we did just start a newsletter, Nature Notes with Hike and Hearth, so we can expand on some of the topics we cover here on the vodcast. Okay, Dustin, are you ready to sign us off for the day?
I sure am. Until next time, friends, keep your eyes in the skies and your hearts in the wild.
Bye, everyone.